Crash Course Instrumentation, Episode 22. Open verse short, what switches really control. Intro. Hey everyone, welcome back to Crash Course Instrumentation. In this episode, we're diving into one of the simplest and most misunderstood concepts in electrical systems, the difference between an open and a short. While switches seem like basic devices, they teach us something profound about voltage, current, and energy. Today we'll walk through real-world analogies and visuals to explain how opens and shorts affect circuits and why switches work the way they do. What is potential? Let's start with a basic idea: potential energy. In an electric circuit, potential energy per charge is called voltage. Just like pressure in a pipe pushes water, voltage is what pushes electric charge. Higher voltage, more potential energy. So when we talk about potential, we're always talking about how much energy a charge gains or loses moving between 2 points, power sources and loads. In every circuit, there's a source, like a battery or power supply, that increases the potential. And there are loads, like motors, lights, or resistors, that decrease it, turning that energy into work. Think of it like a pump pushing water uphill, the source, and then the water spins a turbine, the load, as it flows back down. The open circuit. Now let's talk switches. When a switch is open, current can't flow. But here's the interesting part. You can still have a voltage difference across an open switch, and what you don't have is current. That's key. Imagine air trapped behind a valve. Pressure builds up, but no water flows. That's an open switch. Voltage is waiting, but nothing happens. When a switch is open in the upper half of the circuit, the top builds up high potential, but the rest drops to low. When it's open in the lower half, the whole top half stays high and only the bottom drops to low. Either way, no current, no energy delivered to the load. The short circuit. Now let's short something. A short creates an ultra-low resistance path between 2 points. That means almost no voltage can exist between them. But tons of current can flow depending on what's connected. This is why short circuits are dangerous. They bypass the load and dump all the source energy in the wrong place. And if you short across a load, that load doesn't get any voltage. So it can't do work, it's been skipped over. All the energy goes elsewhere. A visual recap. Here's the key takeaway. Opens, stop current, but can still hold voltage. Shorts, kill voltage, but let current rip. Voltage is potential between 2 points. It doesn't live at a single spot. And that's what makes understanding switches so tricky. You have to see the whole path. A real-world tips. Use a multimeter to check if voltage exists. Across a switch, not at just one terminal. Don't assume an open switch means no voltage. Don't assume a closed switch guarantees voltage at your load. Something could be shorted. Wrap up. Switches aren't just on-off devices, they're insight machines. Every time you flip a switch, you're reshaping the potential and current landscape of a circuit. In our next episode, we'll explore different types of switches, from toggles and push buttons to proximity and process switches, and how they fit into the real world of instrumentation. Like, subscribe, and hit the bell so you don't miss it. And join our Facebook group to keep the learning going.